All right, folks, I'm ready to get started. Welcome back, everyone. Welcome back to the last day that we're meeting before the spring break, the end of the 8th week. So next week, spring break, that'll be the 9th week. Then we'll jump into the 10th week. And then we will be essentially walking the path towards the end. The spring break should be viewed as, of course, an opportunity, as I've said several times, for you guys to solidify your knowledge of the stuff that we've covered already and kind of lay the foundation for you to be able to have a manageable second half of the semester where things tend to start piling up pretty quickly. Assignments, more midterms right before the final exam. So a lot's going to happen. So it's a really great opportunity for you to kind of just reflect on what is coming and what you need to do really well and all of that in order to do really well for the entire semester. So make sure you do that on top of having a little bit of fun and taking your mind off of this stuff just a bit, because you are humans and humans do need a little bit of balance in their life. So make sure that you do that, but also prioritize all of this that we do here, because even during the spring quote unquote break, you are still in school. And so you should view it that way. When I was up north, we were in quarters. They did quarters instead of semesters, and spring break wound up being between quarters, which made a lot more sense than it does with semesters. But you do need a spring break, and so it happens. But it happens like right in the middle, and it could easily cut into your momentum if you allow it to. So it's up to you to make sure that that does not happen, that you continue the momentum you've built up already these first 8 weeks, and have like a really good second half of the semester. Are there any questions you'd like me to address before I move forward with today's material? All right, cool. So again, we're dealing with Chapter 10. We finished the proper part of Chapter 10, and now we're going to cover the appendix, which is more, it's a little bit more a complicated version. I don't like to use that word because it can sound intimidating, but it isn't if you spend enough time understanding it. It's a more sophisticated, let's say, version of the stuff that's presented in the main part of the chapter. But ultimately, what is presented here is the way that this model is used beyond these courses, beyond like introductory courses, and into like the business program and other applications that it might have in economics and finance, etc. So it's important that you get introduced to it here. I'm not going to expect you to know it in like the most complicated way that it's going to be presented. I'm going to be very specific about what I expect you to know, but it needs to be presented in a complicated way in order for you to even try to understand what it's trying to tell us, like what the assumptions sort of imply about the way the model operates and the conclusions that you can get from it and the economic meaning those conclusions hold. And so just kind of like, bear with me as I go through this, stay plugged into it, and don't be afraid by anything you see. It's not going to be too complicated. But ultimately, like between this and the next courses, like you are expected to take a business calculus course. And so the business calculus helps you to understand this model better, which will ultimately require you to do like mathematical problems to solidify your understanding of the logic that underlies it. So, there's levels to learning, and this is the introductory one. But again, like if you don't get introduced to this now, then later on it'll be way too foreign for you, and it'll kind of put you at a disadvantage, especially amongst like the groups of other people that you'll likely be working with and against in the business school. But if you're not in business, like I've said before, like it's important for you to just kind of be in tune with like the approach of modeling relationships and how our models sort of reflect like a certain logic that can be used to model other relationships beyond business and economics. And so ultimately the approach that's taken here is very adaptable to all fields that involve some sort of like scientific analysis that involves the scientific method and and then ultimately trying to establish the legitimacy of certain theories that might be based on models that support those theories. So it's just good to kind of keep an open mind about these things and kind of try to see the bigger picture, even though the specifics of the picture tend to be intricate enough that you can get lost in them. So it's important to kind of just in the back of your mind, just kind of stay aware of the fact that even though the model itself is what it is and it's got its own intricacies, like the approach itself has a lot of applicability beyond this discipline. And so even if you're not going to wind up doing business or economics, that there is some value in this for you. All right, so we're dealing with the consumer problem of choosing the optimal choices of the things that consumers wind up buying for themselves, given the fact that things have prices and that there are, of course, limitations placed on all of us, which is like our income, how much money we actually have to spend on goods. And so, therefore, we need a way to sort of model how a person goes about choosing that final set of things they buy. And we looked at this, at the sort of the underlying logic behind the approach to modeling that in the main part of the chapter, in which the consumer had a budget and each good gave them a certain amount of satisfaction, which we term utility in economics. And it's just a ranking system. It's just a way to kind of capture how people feel about one thing versus something else. The numbers themselves don't have any meaning. They only have meaning relative to each other. So if something gives you, 5 utils of utility, which utils are the units of utility, versus something else that gives you 20 utils of utility, what we know is that something else is preferred to the thing that gives you 5. It doesn't mean that something else is preferred 4 times more. The numbers themselves are, again, just a means of ranking preferences over things. So the numbers themselves don't mean anything. They mean something in relation to each other. So how a person goes about choosing something is they basically think about, like, how much satisfaction are they getting for every dollar they spend? So we look at the marginal utility per dollar spent, which then allows us to use marginal analysis to get us to that optimal consumption bundle, that bundle of goods that is chosen by the consumer. And that optimal consumption bundle happens at the point at which the marginal utility per dollar spent is equivalent across all goods. And so we talked all about that and what that means in the last class. If you aren't caught up, make sure you go back and try to figure this stuff out. But I will be covering it again, just in a very different way today, ultimately getting us back to that same point of optimal consumption, that optimal consumption bundle that exhausts the consumer's income, because we assume more is better, so they're spending all of their money, and the combinations of goods that they're buying is giving them at that combination is giving them the same amount of satisfaction per dollar spent across everything that's being chosen. So we'll talk about first what the utility function is, and the utility function is essentially the relationship between a person's overall satisfaction and all the things that they choose. We looked at the individual utility function for this hypothetical person named Cassie last time, who was eating clams, and we saw that she exhibited diminishing marginal utility, meaning that each additional unit gave her satisfaction, gave her positive utility, but not as much as the prior unit, because, as you consume more of things, you like them, but less and less, because you start feeling satiated. You don't really need as much to give you the kind of satisfaction that maybe the first units gave you. And that characteristic, the principle of diminishing marginal utility, we assume to be the defining characteristic of most goods. In fact, all the goods we consider here that people consume. Each additional unit gives them less satisfaction than the prior unit. And so the utility function takes all that into consideration, and it is sort of a way of relating how a person feels about everything they consume. And the simplest case is the utility function we looked at last time, where It was just Casey's utility as a function of just one good that she consumed. From the utility function, we're going to be able to get what are called indifference curves, which I'll talk about when we get to it, and ultimately lead us to the consumer choice that they wind up choosing, given the fact that, again, they are constrained by the prices that they face in markets, as well as the fact that they only have a certain amount of income to spend on the things they want to buy things on. So different people will have different preferences. So Casey had that utility function. You may have a different utility function with respect to clams. Like that first unit of clams may not give you 15 utils like it gave her. It might give you 20, or it might give you 12. Like you may feel differently about how you feel about clams than somebody else, and therefore you will have a different utility function than a different person. Even given an individual's preferences, there may be different consumption bundles that yield the same total utility. So even though our preferences may be different, there will be combinations of goods that will give us a certain amount of overall utility that will be the same for another person. Like another person will have a consumption bundle that will give them that same level of utility, but that will be made up of different combinations of the goods than you. So that's sort of the nature of what an indifference curve is. It's the combination of all the different goods that give a person the same amount of overall satisfaction. And they're kind of curved out like this, which is why I've got this photo there. So indifference curves are used to analyze behavior of consumers for 3 different reasons. First, indifference curves show how diminishing marginal utility determines a trade-off that a consumer makes between consuming more of a good and less of a good. So if you think about like the things that you buy in a certain month, and if you maybe want to switch some things out for other things, like there's a trade-off. There's a rate at which you're able to trade those things off, given that they have prices and also that you have preferences over them, that will either maintain your overall level of satisfaction or not. And the reason why that rate is important, the rate at which you're willing to switch things off, is because diminishing marginal utility will lead to differing levels of overall utility as you consume more of one good and less of another one. And so I'll talk more about that in a second. Second, they provide a framework for a more in-depth analysis of income and substitution effects. We talked about last time how when the price of something changes, there are 2 effects. People respond in 2 different ways. One, if the price goes up, then they tend to substitute away from that good to other goods because, again, the price of the other one has changed relative to the one that had the actual price change, and therefore the person will want to consume more of the cheaper one versus the one that's now more expensive. So that's what we call the substitution effect. And then we also talked about the income effect, that if we think about the amount of stuff that everybody buys as being like a way to represent their income, so representing income not by like some money value, but like everything that can be purchased, then let's say some part of that income is made up by housing, which is 60% of your income, let's say. If the price of that goes up, you're going to substitute away from a version of housing to a different version of housing that's cheaper. But what that's also going to do is it's going to crowd out other things that you are normally able to buy. So your real income, your income in terms of goods, in terms of the value of what it can buy, will actually go down when the price of something that takes up a large part of your income goes up. And that is what we call the income effect. And so using indifference curves, we can identify those effects more precisely. Lastly, indifference curves allow us to illustrate differences in taste between 2 different people and how those differences in taste lead to different optimal consumption bundles. So we can represent preferences of people that are more inclined to buy certain things versus others by specifying a utility function that represents their preferences that have indifference curves as a defining characteristic of them, that will differentiate that type of behavior from somebody else's behavior, which will then allow us to analyze markets in very specific ways for different types of people and be able to understand like why people of a certain group might choose, to buy a certain consumption bundle versus a different group that might choose to buy a different consumption bundle. So indifference curves allow us to get a deeper understanding of the rational consumer. Last time we talked, not last time, but the time before that in the marginal analysis chapter, we introduced this concept of rationality. And we talked about how in behavioral economics, we're sort of studying how people sometimes don't behave rationally. And when we're talking about rational behavior in economics, we're talking about people choosing the options that are going to always make them best off. So that's what this is all about. It's understanding how the consumer that is choosing the option that's going to make them best off is ultimately getting to that point of consumption that represents what they buy with their income, given the limitations they face. Anyway, this is all very sort of general stuff. Let's get into the actual meat of this. All right, so first we'll talk about indifference curve. So over here you've got a three-dimensional utility function. So the utility of Kc with respect to the clamshite was a two-dimensional relationship. When we're talking about utility as a function of two goods that can be consumed by a consumer, and that's all we're going to assume here. We're going to assume that there's only two goods in the world the consumer can consume. We're talking about that becomes a three-dimensional relationship. Utility is a function of how much good X is consumed and how much of good Y is consumed. When you have three-dimensional relationships, you can't represent those graphically in just the XY plane. So you need a third axis for that. The third axis is the Z-axis. So if you have like your normal XY graph, then the Z-axis would come out from the screen, and there would be like a three-dimensional shape. So here the XY plane is considered to be just like the bottom of a three-dimensional shape, and the shape is assumed to be kind of like a bowl, kind of like a bowl that kind of converges on a top. And the height of the bowl is going to measure the utility. And along the edges, we're going to be able to measure the amount of good X and the amount of good Y that's being consumed. So this utility function of three dimensions, again with the height being utility, can be sliced at any level of the bowl. And you'll have sort of like an outer edge of the bowl that would kind of be a rounded edge. And that's going to represent combinations of X and Y that give the consumer the same amount of overall utility. As you go higher on the bowl and you slice it at a higher edge, then that's going to represent, like the edge of it, that contoured curved line is going to represent combinations of X and Y that all give the consumer a higher level of utility than like this one here. So these lines along this three-dimensional utility function are known as indifference curves. So a contour map that maps consumption bundles yielding the same amount of total utility is known as an indifference curve. So a utility function, again, represents a person's preferences over the goods they can consume and how much utility they can get from the varying combinations of those goods. Utility is on the Z-axis. Again, it is the height. You can slice that utility function at any level. In this example, we're only slashing it at two levels. We're slashing it at the level where utility is equal to 20, and then we're slashing it at the level where utility is equal to 30. And you're getting those like rounded contour edges of this like three-dimensional bowl shape that is the person's utility function. If you squash down those edges and then just kind of draw them on this XY plane, then you get what are called indifference curves. And you can study this three-dimensional relationship in a two-dimensional setting, and it becomes a little bit easier to sort of manage, at least visually, because it's hard to sort of visualize three-dimensional relationships. And so down here, this is what you're essentially seeing. You're seeing like the outer edges of like this like three-dimensional like bowl-shaped thing, and each edge represents like a kind of the outer edge of a slice of the height of this utility function at a particular level of utility. So this line here is an indifference curve, which represents this edge of the utility function that has like, like this combination of goods here that has a lot of Y and a little bit of X, and that combination of Y and X give the consumer 20 utils of overall satisfaction. And then there's all sorts of combinations of x and y along it, like this one down here has a little bit of y and a lot of x, but that combination of those two goods also gives the consumer an overall utility of 20 utils. So all combinations of x and y along the indifference curve give the consumer the same amount of overall satisfaction. And so the consumer is indifferent between consumption bundles along the indifference curve, and that's why it's called an indifference curve. Then we've got this one over here. Again, that's the outer edge of the slice of the utility function at a higher level where utility is equal to 30 units. You smash that down, you get this line here on the XY plane. It's going to be further away from the origin because, again, it represents like a higher level of overall utility. So all combinations of X and Y on this indifference curve are all going to give the consumer 30 utils. So all combinations of X and Y are going to give the consumer more utility overall than all combinations of X and Y along this one. So this one over here has, this much Y, this much X. It gives the consumer an overall utility of 30. And then this one has a lot more X, a little bit of Y. And that consumption bundle has also 30 utils worth of satisfaction for the consumer. So again, all combinations of X and Y along this indifference curve will give the consumer the same level of utility, 30 utils, and the consumer will be indifferent between those consumption bundles as well. The collection of the indifference curves that represent a given consumer's entire utility function, with each indifference curve corresponding to a different level of total utility, is known as the indifference curve map. So this is an indifference curve map. It only shows two levels on here, but you could slice this utility function at any level and again, kind of get that outer contour edge and then kind of trace it down here, and then you'll get more indifference curves. So really here are an infinite amount of indifference curves, each one representing higher or lower levels of utility, depending on whether they're closer or further away from the origin, where y and x equals 0. So there's an indifference map here for every single level of utility. There is an indifference curve, but we don't see them all, but they're always there. No two individuals have the same indifference map because no two individuals have the same preferences. So this utility function is specific to one person and how they feel about the two goods that they consume and how they're willing to trade off one good for another, depending on how marginal utility is diminishing as they consume more or less of each good, based on how they feel. So you could represent people's preferences differently by specifying different utility functions. Economists believe that regardless of the person, every indifference map has four general properties, though. So regardless of how the utility function might end up looking, it will have certain properties that will be consistent throughout all of them. So the first one is that indifference curves will never cross. So if the curves cross, you would wind up with a situation like the one you see here, where it's unclear how much total utility this combination of X and Y give the consumer, because it lies both on this indifference curve that corresponds to a utility level of 100, and this indifference curve that corresponds to a utility level of 200. It doesn't make sense. Like, how does this person feel about this one? Well, does that one have 100 utils or 200 utils? It's unclear. The utility, the indifference curves will never cross, regardless of how a person might feel about the relationship between the two goods. So they cannot cross because every consumption bundle must correspond to a unique total utility level. Property 2, the further from the origin, the higher the utility. We assume that more is better, and that's essentially why. So at A, more of Y and more of X are consumed than at B, so therefore A will be consumed to B. A will be preferred to B. But also we understand that the indifference curves are corresponding to different heights of that three-dimensional relationship. That's ultimately what it is. All right, I already said that. Property 3, indifference curves slope downwards. So here are 6 consumption bundles, A, B, C, D, E, F. And they all yield the same level of overall utility. They're all on the same indifference curve. So a consumer is indifferent between the combinations of X and Y represented by A, represented by B, C, D, etc. As we move down along, let's say from A to B, the consumer has to give up some of A in order to get more, some of good Y in order to get more of X. So there's a trade-off that the consumer faces in order to maintain their overall level of satisfaction as they're moving from one consumption bundle to another. And so because of that trade-off, because something is being given up in order to get more of something, you're going to have like a negative relationship. And therefore, the indifference curve is going to slope downward. Property 4, indifference curves have a convex shape, meaning they have like kind of like this bow shape, bow towards the origin, like a bow you would use to shoot arrows. It's kind of like bowed into the origin being this point here. So the diagram shows that the slope gets flatter as you move down along the indifference curve. So over here, if you were to, if you haven't taken calculus yet, like you've taken basic math, you understand what a slope is, the rise over the run. That is how we can get the rate of change of a line that has a constant slope. When you have a curve like this, you can't do that because, again, the rise over the run at any given point is changing as we're moving along it. So there's a method that we use that allows us to say, well, at every point there's a line that we could just touch that point at that will give us an approximation of how y is changing with x by taking the slope of that line. The way that we actually wind up doing it is explained to you in calculus to the point where it becomes clear that it's an effective way of doing it. If you haven't learned it yet, I suggest you learn it because it's good stuff to know. But what you should know is that the slope on the line is getting flatter and flatter. That means that in absolute terms, meaning like if you're thinking about the slope in absolute value, so this one has a bigger slope than this one, even though if we were to think of them in negative terms, this one would actually be bigger than this one. I'm sorry, this would be actually would be smaller than that one because this one would be a bigger negative number than that one, so this one would be smaller than that one. But in terms of absolute numbers, the trade-off is bigger here than it is here. So basically, as the person is consuming more of X and less of Y, they require less of Y to trade off to get more of X. And I'll talk more about that in a second. So the feature arises from diminishing marginal utility. So remember, earlier units of a good are worth more in terms of extra satisfaction a person gains than later units of the good. So if you think about being at point A and having a little bit of X and a lot of Y, if the person wants to consume a little bit more of X, in order to maintain the same level of satisfaction, they're going to have to give up some of Y. Now the question is, how much will they give up of Y? Well, it depends on like how much an extra unit of X is worth in utility versus how much an extra a less unit of Y is worth in terms of utility. So we see that this is a very early unit of X. So that means that the marginal utility of the person, how the person feels about consuming X at this early point is going to be pretty high versus like over here where the person has consumed a lot of X, and so additional units of X aren't worth that much in terms of like marginal utility. So because this unit of X is worth more than this unit of X in marginal utility, then this one, then to add an additional unit of X over here is going to require giving up more of Y in order to maintain overall satisfaction at the same level than over here, because this one's not worth that much in terms of marginal utility. And so if you want to consume one more unit of X, you only have to give up a little bit of Y, and therefore the trade-off becomes less as we move from left to right. And that's why indifference curves have a convex shape. So goods that satisfy all four of these properties of indifference curve maps are known as ordinary goods. All right, now let's talk about indifference curves and the consumer choice, the optimal consumption bundle that we talked about in the main part of the chapter. It's important to understand how the analysis here relates to what we did in Chapter 10. We're not offering a new theory of consumer behavior in the appendix. Just as in Chapter 10, consumers are assumed to maximize their overall total utility. We know that consumers will follow the optimal consumption rule from Chapter 10. The optimal consumption bundle lies on their budget line. The combination of everything they buy is going to exhaust their income. And the marginal utility per dollar spent is going to be the same for every good in the bundle at the optimal consumption bundle. With indifference curves, we can derive the optimal consumer behavior in a way that yields deeper insights into consumer choice. All right, in order to get there, we need to understand that trade-off that the consumer is making as they're moving along our indifference curve a little bit better. So we're going to let the marginal utility of good X, the extra utility gain from consuming additional units of X, we're going to let that equal MUX like we did in the proper part of the chapter. We'll let the marginal utility of good Y equal MUY, which again is the extra utility gain from consuming additional units of good Y. A change in the consumption of good X. So if they're moving from like this consumption bundle here to this consumption bundle here, they have to give up some of Y and in order to get additional units of X. So we're going to say that the change in the amount of X the consumer consumes, let's say from this point to this point, is going to be represented by this term here. The triangle represents change in mathematics. So change in quantity of X is what that is. So if the consumer is moving from this consumption bundle to this consumption bundle, they're giving up some of Y and they're gaining some of X. So they're consuming extra amounts of X, which is represented by that. And when they consume more of X, they're going to gain more satisfaction from it. So it's going to carry additional marginal utility. So going from this point to this point, this will represent the total utility change in consuming more of X. They're going to consume more of X, the change in QX, and that's going to carry some extra marginal utility with it. As we're moving from this consumption bundle to this consumption bundle, the consumer is consuming less of Y. So they're going to consume less of Y that's going to be represented by some change in the quantity of Y. So again, you're represented by the triangle to represent change in QY. And that is also going to carry a change in marginal utility. There's going to be some loss in satisfaction from consuming less of Y. So the change in total utility due to giving up some of Y from going from this consumption bundle to this consumption bundle will be equal to the change, the amount of Y that the consumer is losing consumption of, times the amount of marginal utility that quantity of Y represents. So they're losing some satisfaction from the amount of Y that they're not consuming anymore. So along the indifference curve, in order to maintain their overall level of satisfaction as they're moving from one consumption bundle to another, those two changes in overall utility have to be equivalent. So along the indifference curve, the marginal utility value of the amount of Y that one is losing, and there's a negative in front of that because again, from moving from this consumption bundle to this one, you're losing some quantity of Y that's being consumed in order to get more quantity of X. So on this side, it represents what you're losing in overall utility from losing some consumption of Y, and this side represents the addition of extra utility you're getting from consuming more units of X. And again, along the indifference curve, they have to be equal in order to maintain the overall level of satisfaction. So that's what we're going to get there. So what we're trying to do here is come up with an expression for the slope of our indifference curve. And the slope of any curve is the change in Y over the change in X. So we have to get this expression into the change in Y over the change in X. We have the change in Y on the left-hand side. We have the change in X on the right-hand side. So we need to use a little bit of algebra here to get those terms together. So I'm going to divide both sides by MUY to get that term on the right. So that'll cancel those out on the left. And now on the right-hand side, I'm going to divide both sides by the change in QX to get that on the left-hand side. And so these cancel out here. And so what we're left with is this expression for our slope of our indifference curve, which is the change in QY over the change in QX. And what we've derived here is that is equivalent to the ratio of the marginal utility of the good on the x-axis to the marginal utility of the good on the y-axis. It's just another way to express the trade-off that's being made, in this case, in terms of marginal utilities. So as we're moving from left to right, the consumer is giving up some of y and some of x, and that can be represented as the ratio of the marginal utility of x to the marginal utility of y. It's a mathematical result, but it does make intuitive sense, and we will get to that in a second. So this is known as the marginal rate of substitution. It is the slope of the indifference curves. It's the rate at which a consumer is willing to substitute one good for another and still maintain the same level of utility. It's the marginal rate of substitution. I won't need you to know how to derive it. You should understand what this means, though, and also just know what the marginal rate of substitution is in general. Now, along an indifference curve, we see that there is diminishing marginal rate of substitution, meaning the slope is getting flatter and flatter as we move from left to right, and I already talked about why. Because again, earlier units of x are worth more in marginal utility than later units of x due to diminishing marginal utility, and that is what causes the marginal rate of substitution to diminish from left to right. So we have diminishing marginal rate of substitution, which is the flattening of the indifference curve as you slide down them to the right, reflecting the same logic as the principle of diminishing marginal utility. All right, so with this information, we can define ordinary goods, again, the goods that have the properties of indifference curves we talked about, which account for the great majority of goods in any consumer's utility function. So most goods that people consume will fall within the category of ordinary goods. A person's overall utility function will always exhibit diminishing marginal rate of substitution along their indifference curves, because again, people always, as far as like their relationship to individual goods, they always exhibit diminishing marginal utility. A pair of goods are ordinary goods in a consumer's utility function if they possess two properties. The consumer requires more of one good to compensate for less of another. The consumer experiences a diminishing marginal rate of substitution when substituting one good in place of the other. A lot of different ways of saying the same thing. So it's not like I'm saying a lot of different things. I'm just kind of giving you a lot more insights into the same concept over and over again. What indifference curves are, how they work, why the trade-off changes along them, how that relates to diminishing marginal utility, what that trade-off is called, the marginal rate of substitution, what it's equivalent to, the ratio of the marginal utility of good x to the marginal utility of good y. And what happens as we move from left to right? There is diminishing marginal rate of substitution due to diminishing marginal utility. All right, now let's go back to our budget line. Remember, the budget line worked just like the production possibility frontier, and it represented essentially the consumption possibilities, the possibilities that exist for a person in terms of everything that they can buy given their income and the fact that things have prices. Again, we're still working in a two-good world where only two things are available to be purchased and consumed. And so we're still going to have like that very simple line that's going to make a triangle on a graph that's going to represent the consumption possibilities. We're going to let M represent the consumer's income, which can be any amount. We're going to let PX and PY represent the prices of goods X and Y respectively. We'll let X and Y represent the quantities of goods X and Y respectively. So given this notation, the consumption possibilities, also known as the budget set, may be expressed mathematically as the total value of everything that can, of all of good X that can be bought, which is the amount of X times its price, plus the total value of all of Y that can be bought, which again is the total amount of Y that can be bought times its price, and that's going to equal the person's income. So this is the budget set. It will eventually become the budget line. We also call it the budget constraint, and it creates the consumption possibilities. This is basically the same thing we already covered in the main part of the chapter. So the budget line is the bundles. The budget line represents the bundles of good that exhaust the consumer's income. All right, so here is a budget line again with having good Y on the Y-axis and good X on the X-axis. The vertical intercept is the point which the consumer spends all her money on good Y. So basically, her income M divided by the price of Y will get us that vertical intercept. It tells us the most amount of Y that the person can buy if they only bought Y. The horizontal intercept is going to be the point that represents the total amount of good X the consumer can buy if she only spent all her money on good X. So again, her income is M divided by the price of X. That's going to give us the total amount of X that can be bought if the consumer only bought X. And remember, any consumption bundle along the line represents the consumption bundles that will exhaust all her income, meaning she's spending all of her income. And inside of it means that she's consuming combinations of goods she can afford, but she's not using all of her income. And then outside are combinations of goods that she cannot afford. A way to understand the slope of the budget line is to consider the opportunity cost of consuming only one good. So we can again think of the slope as the opportunity cost. As you're consuming more of one, you have to give up some of the other. In the same way that we thought about the slope of the production possibility frontier being the opportunity cost of producing more of one good in terms of giving up some of the other good that's being produced. So the opportunity cost of only consuming good X is giving up all of Y. So again, the opportunity cost is going to be in terms of, for X is going to be in terms of Y. So it's going to be a ratio of total possible Y consumed over the total possible X consumed. That's going to be the opportunity cost of consuming only X. The total possible of Y that can be consumed is equal to M over PY. And then the total possible of X that can be consumed is equal to M over PX. So this is a very general way of talking about the opportunity cost of consuming good X along this line. So now you've got a ratio over a ratio. There's a negative in there because there is a trade-off. As you're increasing consumption of one, you're giving up the other. That's why the negative's in there. All right, we've got a ratio divided by a ratio in mathematics. If you have a ratio divided by a ratio, that's equivalent to the top ratio times the reciprocal of the bottom ratio. So you've got the top ratio negative M over PY times the reciprocal of the bottom ratio, which is equal to PX over M. Now we can cancel out the M's, and that means that the slope of our budget line can be expressed as the negative ratio of the price of X to the price of Y. That's another way to express the opportunity cost of consuming more of X and less of Y in terms of how much is being spent by expressing it as a negative ratio of the price of X over the price of Y. This is also known as the relative price of good X to good Y. It's also known as the market rate of substitution. It's the rate at which the goods can be exchanged in open markets. Whereas the marginal rate of substitution, the slope of the indifference curves, represents the rate at which a person is willing to trade off one good for another in order to maintain their overall level of satisfaction. So you've got a trade-off that's being set upon the consumer by markets, right? Prices are being set in markets. There's a demand and supply for good X. That's setting a price, PX, equilibrium price. That's what we're seeing there. There's a market for good Y. There's a supply curve. There's a demand curve for Y. They meet in the middle. They set an equilibrium, and that's what PY is. It's the equilibrium price for good Y. So those two goods have been priced in markets, and there's a rate at which you could trade off one good for another good. So, given their prices, then that tells you what the real trade value is, meaning like how much of good X you need to get one unit of Y and vice versa. So one can also think of it as the market rate of substitution. Suppose a consumer purchased, let's say, bundle A which lies on their budget line, in which 3 units of good Y are being consumed and 4 units of good X are being consumed. If the consumer purchased bundle B instead of bundle A, then she would gain an additional unit of good Y. So she could move along her budget line, and this bundle is affordable as well, and again has an extra unit of Y and 1 less unit of X. To afford bundle B, she has to give up 2 units of X. So we can look at this as your standard sort of slope expression where you have the change in Y over the change in X. The change in X here is 2. For every unit of Y the consumer purchases, she must give up 2 units of X in order to be able to afford the additional unit of Y, is what that's telling us. Thus, the market rate of substitution is equal to 4 minus 3 over 2 over minus 4, which is equal to 1/2, which is going to be the slope of our budget line. It's equal to 1/2 in this case. And what that tells us is that to buy 1 additional unit of X, the consumer has to give up half a unit of Y. And to gain an additional unit of Y, they have to give up 2 units of X. So just like the opportunity cost of the good that was being produced in the production possibility frontier on the Y-axis was the reciprocal of the opportunity cost of the good on the X-axis, so is the case with the market rate of substitution, which again represents the opportunity cost of consuming more of X. You can get the reciprocal of that, and that'll get you the opportunity cost of consuming more of Y. In terms of the relative price perspective, X is worth half a unit of Y, and Y is worth 2 units of X. In the 2 good case, the relative prices are reciprocals. All right, now let's see what happens when there is a change in income. So the best way to think about what happens with a change in income is to think about what happens to the intercepts, like the most that can be purchased of either good. And again, you have to think about the intercepts as being the ratio of the income of a person to the price of the good. So here we've got the overall income divided by the price of Y tells us how much Y can be purchased. Here's the overall income divided by the price of X tells us how much X can be purchased if only X was purchased. And then, of course, along the line represents combinations of the two that can be purchased that still exhaust a person's income. So given the slope of the budget line, we know is a negative ratio of the price of X to the price of Y. The increase in income does not affect the price of the slope, because if a person's income increases, let's say, then that's not affecting the prices of the goods in markets. So therefore, the slope remains constant. So what's going to happen when income increases is that the entire line is going to shift out. And if income decreases, the entire line will shift in a parallel fashion. The slope will be maintained. So the thing to consider again is like the intercepts, just to kind of figure out, how best to change the budget line when incomes change. The vertical and horizontal intercepts of the budget line both increase as the consumer's income increases, right? We've got a higher income, let's say M1 is greater than M0, and now it's being divided by the same price. So the most that they can buy of Y is going to be bigger. The most they can buy of X will be bigger. So it'll be M1 divided by PX. When income increases from M0 to M1, where M1 is greater than M0, the budget line has a parallel shift to the right. If income decreases from, let's say, M0 to M2, so income is less, then the line will have a shift towards the origin, and it will, again, maintain its slope, so it'll be a parallel shift. Let's consider what happens when a price changes, but incomes remain the same. So here's the initial budget line, and suppose the price of good X decreases. So the price of good X goes down. So here's our original intercept. We have income divided by the price. And you can buy a certain amount of X if the person only bought X. If the price of X goes down, what's going to happen to this intercept? Go ahead. If the price of X goes down, what's going to happen to this horizontal intercept? So think about what it means. You have to think about what it means. So the price has gone down. This is your income divided by the price. You can purchase more, right? You can purchase more because your income stayed the same and now the price of X has gone down. So you have a number that's not changing divided by a smaller number, you're going to get a bigger result. And so therefore the horizontal intercept will move outwards, which will rotate the budget line outwards. So to consider what's going to happen in terms of a price change, you have to consider which price is changing and then think, is the price increasing or decreasing? If the price is decreasing, then the most that person's going to be able to buy that good is going to increase. So the intercept will increase. But if the price goes up, that means the person will be able to buy less of the good. And so then, in this case, the budget line would pivot inwards in the opposite case. So an increase in the price of good X leads to a clockwise rotation of the budget line. It would be the opposite way if it was the opposite case. All right, so now let's talk about the optimal consumption bundle. Now that we understand how to represent preferences within difference curves, and we're able to demonstrate the limitations on those preferences to consume by the budget line that, again, represents not just the person's income, but also the fact that things that they buy have prices. So the objective of the consumer is to choose a consumption bundle that maximizes his or her utility or overall satisfaction. Due to scarcity, the consumer must select a bundle that lies inside the budget set, an affordable bundle. So we're gonna have both the indifference curve framework, which represent the preferences, with the budget line representing the constraint on those preferences. So here's a consumption bundle. It's A. It falls within the person's budget. It exhausts their income. It's on her budget line, and it's also on this indifference curve, which gives her a certain level of satisfaction that is represented by this level of utility. The question is this the consumer doing the best she possibly can at that bundle? What do you think? Can she do better than that bundle? Can she get more satisfaction from her dollars than just consuming at that point there? Remember, there's an indifference map here. There's an infinite amount of indifference curves here, right? All right, so here's a higher indifference curve that has always been there. I just brought it up, but it was always there because there's an infinite amount. This one, again, represents consumption bundles that give the consumer higher levels of overall utility than all consumption bundles on this lower indifference curve. So we've got bundle B there. Bundle B is preferred to bundle A because it lies on the higher indifference curve, and it's still affordable. It's still a combination of X and Y that the consumer can afford and will exhaust her income. Do you think the consumer can do better than this? She can, right? Why? Because there's higher indifference curves that represent higher levels of satisfaction that she can gain from consuming different amounts of goods X and Y that fall within her budget. So here is the consumer equilibrium. And there is an indifference curve there that I apparently forgot to put on there. I was trying to simplify this for you because it can get very complicated. And apparently I forgot to put that higher indifference curve there. So there is a higher indifference curve here that is just touching this point here that represents the point of optimal consumption for the consumer. Don't worry, we'll see the consumer equilibrium again in a second, which is the optimal point for the consumer. The equilibrium consumption bundle is the affordable bundle that yields the greatest utility to the consumer. We talked about the consumer equilibrium in the main part of the chapter. The concept here is no different. It's just being represented in a different way, in a more complicated way, but complexity is needed to represent a complicated world. And so if you don't have complicated tools, you can't really understand the world in the way it needs to be understood. And so you have to have more complexity. Now the consumer would want to consume a consumption bundle out here, which would be on a much higher indifference curve, but that one lies outside of the budget set, so she cannot afford it. So this consumption bundle lies on the highest possible indifference curve that she can consume on given her budget, and therefore it is the equilibrium. It is the one consumption bundle that she prefers the most and is affordable. At the equilibrium consumption bundle, the slope of the indifference curve is going to be equal to the slope of the budget line. So the marginal rate of substitution will be equal to the slope of the budget line, which is equal to the ratio of the price of X to the price of Y. So recall that the marginal rate of substitution is itself equal to, again, the ratio of the marginal utility of X to the marginal utility of Y. At the optimal point of consumption, that is going to be equal to the slope of the budget line, which is equal to the negative ratio of the price of X to the price of Y. So one can again gain more insight into the consumer equilibrium by considering that at the equilibrium, the marginal rate of substitution is equal to, again, the slope of the budget line. Now, we can cross-multiply here, get basically PY to the left and MUY to the right. So the first thing I did was I multiplied the marginal utility of Y on both sides, which got that to the right-hand side. These cancel out. And then I divided both sides by the price of X to get that on the left-hand side, which then got me to this expression here. So at the optimal consumption bundle, as was the case at the optimal consumption bundle in the main part of the chapter, the consumer is getting the same amount of extra utility per dollar spent across all the goods that she consumes. The marginal utility per dollar spent, marginal utility of X divided by the price of X, is going to be equal to the marginal utility of Y over the price of Y. The marginal utility per dollar spent across all goods is equal. We looked at this in a chart, in a table last time to really understand what that means. And now we're kind of just representing it symbolically, but it means exactly the same thing. It just is being represented in a more complicated way. So this tells us that at the consumer equilibrium, the amount of utility per dollar spent on each good is going to be equivalent. So here is the consumer equilibrium again. Here's that indifference curve that I left off of that other slide, which I'll put back before I upload this. But anyway, here's the consumer equilibrium. At the consumer equilibrium, the consumer is consuming on the highest possible indifference curve, and again, within their budget line. So this is the consumption bundle that gives her the highest amount of satisfaction and is affordable. At point A, the slope of the indifference curve. So at point A here, the slope of the indifference curve is going to be greater than the slope of the budget line in absolute value. That tells us that the marginal rate of substitution is greater than the relative price, which means that the marginal utility per dollar spent on good X is greater than the marginal utility per dollar spent on good Y at this consumption bundle. So therefore, the consumer is going to want to spend more of her money on X than Y, because each additional dollar spent on X will give her more satisfaction than spending those dollars on Y. As she consumes more of X and less of Y, diminishing marginal utility sets in, and eventually it gets her back to C, where the marginal utility per dollar spent is going to be equivalent across all the goods, because again, each additional unit of X she consumes will give her less and less marginal utility. So the marginal utility per dollar spent will diminish as she moves from left to right along a budget line, to the point where once again these are equal. Same thing on the right side. Over here, the marginal utility per dollar spent on good Y is greater than the marginal utility per dollar spent on good X. And so the consumer will want to buy more of Y and less of X because it gives her more satisfaction. And diminishing marginal utility will eventually make them equal again, getting her back to that optimal equilibrium. So again, at A, this means the consumer is willing to give up more of Y to get an additional unit of X. As this occurs, each successive unit of X is worth less in utility due to diminishing marginal utility, eventually bringing the consumer to the point where marginal utility per dollar spent across all goods is equivalent. So one thing I will need you to do is be able to draw for me the consumer equilibrium using indifference curves and budget lines. So that's one thing you will be asked to do. I mean, you have to, the whole point of presenting it like this is for you to really understand what it means to be here and why that is of any relevance. And so the first part of the chapter explains that in like very general, like practical ways. And then this part presented in the way that we actually need you to understand it. And all that is meant to help you understand why this means what it means. But ultimately, the math that you'll learn later on, if you wind up going further, will really help you understand it. Because in the world that we all live in, our overall utility is not a function of two goods, it's a function of all the goods we buy. And so the relationship between our utility and the goods we buy is multidimensional. It's like a lot more than 3 dimensions, and you can't represent it visually whatsoever. But this is the best way to represent it in terms of graphs, in terms of providing you just like basic insights into how you can understand why this is what it is. All right. One thing to note, we can represent, like I mentioned, people's preferences differently by specifying different utility functions, and those will yield different indifference maps, which will have different marginal rates of substitution, which will represent a person's preferences. So here we've got a situation where these people, Tex and Mohan, they both like potatoes and rice. Let's say they're both consuming at this point here on their indifference curves, where they're consuming 5 potatoes and 3 units of rice. Let's say they're going to move along it. They want to consume an additional unit of rice. So for Tex to consume an additional unit of rice, based on his preferences, he only has to give up 1 potato. For Mohan, in order to consume an additional unit of rice, he has to give up 2 potatoes. This means that Mohan just overall prefers rice more than Tex. So he values rice more, and therefore the marginal rate of substitution is going to be greater for him than for Tex, and so therefore the indifference curves are going to be steeper, just representing the fact that, again, Mohan has a bigger preference for rice than potatoes overall, regardless of how much of each he's consuming. So their difference in preferences show up in their marginal rate of substitution of potatoes for rice. All right, now let us talk about what happens to that optimal consumption bundle when prices and income change. That's another thing I'm going to expect you to do. I'm going to expect you to be able to draw for me an optimal consumption bundle and then show me what happens when any one of things could happen. A price of either one goes up or down. Income goes up or down. What happens to the optimal consumption bundle? You have to show that to me. In order to do that, you have to understand what this means. So that's what all this is about. All right, so this is a situation where the consumer is consuming at her optimal consumption bundle on the highest indifference curve possible that falls within her budget. A change in the price of a good will lead to a change in the equilibrium consumption bundle. So a change in the price of a good means that the rate at which the goods can be exchanged in markets will be different. That means the slope of the line will be different. That means that the point at which optimal consumption will happen will be different than where it already is, because at the optimal point of consumption, the marginal rate of substitution is equal to the market rate of substitution. If the market rate of substitution changes, then the marginal rate of substitution needs to change as well in order to get the consumer to a new optimal equilibrium. So the consumer is initially at point A, consuming some of Y and some of X. We're going to consider that the price of X decreases. So the price of X decreases. That means that the consumer can buy more of X if she only purchased X. That means the horizontal intercept moves out. That means the budget line rotates outward. Remember, there's an infinite amount of indifference curves here. So that's going to get her to a higher indifference curve. She's going to be overall more satisfied with the things that she's able to buy now, because, again, she can buy more of other things because one of the prices has gone down. So here's a higher indifference curve. In fact, it's the highest indifference curve she can consume on, the point that's going to give her the most amount of satisfaction. So at point B, that's going to be the new point at which now she is using all of her income and she is as satisfied as she possibly can be. So precisely where the new equilibrium point will lie along the new budget line after a price change depends on the consumer's preferences. It depends on the shape of their indifference curve. Depends on how they feel about the goods overall. This person tends to like good Y a little bit more than X, since it tends to be flatter most of the way. Anyway, just based on this person's preferences, which are embodied by her indifference curves, and the fact that the price has changed, that has led this consumer to now consume at this point, where she is consuming less of Y and more of X. So what this also tells us is that in terms of how she views goods X and Y, the price of X went down, she consumed more of X, and she also consumed less of Y. That means that she views them as substitutes. As the price of one goes down, she buys more of one and less of the other. So that's another insight that we can gain from this analysis, that just based on what happened here, given the person's preferences and the change in price, that these two goods are viewed as substitutes by the consumer. So you can get those insights from markets by kind of connecting the data you might have on how people respond to price changes in markets to what we know about their preferences based on like consumer satisfaction surveys, in order to figure out what people how people view the goods in particular markets. So goods X and Y are substitutes if an increase in the price of X leads to an increase in the consumption of Y, and if an increase in the price and a decrease in the price of X leads to a decrease in the consumption of Y, which is what happened here. A decrease in the price of X led to a decrease in the consumption of Y. We know that goods X and Y are complements if an increase in the price of X leads to a decrease in the consumption of Y, and a decrease in the price of X leads to an increase in the consumption of Y. Again, complements like, coffee and sugar, they're purchased together. When the price of coffee goes up, people buy less coffee, but they also buy less sugar, right? Anyway, these are viewed as substitutes based on what we see here. All right, now let's think about what happens to the optimal consumption bundle when income changes. So here we have a situation where the consumer is consuming at A, that's her initial consumer equilibrium, based on her preferences and her income. Let's say her income has gone up. If her income has gone up, that means the budget line shifts out in a parallel fashion, and that means now she can consume at a higher indifference curve that will give her a higher level of satisfaction. She's going to consume on the highest possible indifference curve, the one that's just touching the new budget line. So that's going to be this one here. So she's going to consume now at B. As in the case of price change, the exact location of the new equilibrium point will depend on the consumer's preferences, just based on what the preferences are. If I'm not going to specify, oh, this person's preferences are this type or this type, so you should draw it in this way. No, I'll just say preferences. So just be as general as possible, just like indifference curves, normal, nothing too complicated there. Again, it's going to be about you understanding what the equilibrium means and how to represent that with indifference curves and budget lines, and how to represent a change in the market environment and how that results in a new market equilibrium, a new consumer equilibrium for the consumer. It's not hard, but if you don't understand the model and what it means, it is hard. And so if you understand it, you're good. You're pretty much at the point of understanding if you've been listening to me this entire time. So that's a good thing. All right, so income went up, and when income went up, more of good X was purchased, but more of good Y was purchased as well. What that also tells us is that both of these goods are considered normal goods by this consumer. Normal goods, income goes up, people buy more. Inferior goods, income goes up, people buy less, right? So neither of these goods are considered inferior. Since more of both goods are consumed when income goes up, we can conclude that both goods are normal goods. So here's a situation where the consumer views the goods as inferior. So their preferences are a lot different here. They're like very steep. Here's the original budget line. There's the original equilibrium. And income has increased. So that's what this blue line is. That's the increased income. The new point of optimal consumption is now at this point here where more of Y is consumed, but actually less of X will be consumed. So based on this person's preferences, when her income went up, she wound up consuming less of X and more of Y. That means Y is considered a normal good by this person, but X is considered an inferior good. And again, the person's preferences, how this person overall feels about the things they buy is represented by their utility function, which the edges of can be represented as indifference curves. Again, representing different perspectives on how people feel about things. All right, so one other thing we can do is identify the income and substitution effects. So again, like the thing you really need to be able to do is just represent the changes in the consumer equilibrium based on price changes and income changes, and just understand what the equilibrium means. And just the basic terminology that I covered in the chapter, like all the numerical stuff and like the symbolic stuff that I derived here was just meant to provide you insights into why this equilibrium ultimately means the same as the one that we talked about in the main chapter, where the marginal utility per dollar spent is equivalent across all goods at the optimal consumption bundle. But I won't need you to be able to show me how to do that, because I know that's a little bit more complicated than the stuff you're used to seeing in this class. But again, this model, the way I presented it here, the insights you can gain from it is what you need to learn. And so make sure that you do understand it. Okay, I'll show you one other thing we can get from this. So we can combine our analysis of price and income changes to gain a better understanding of the effect of a price change on consumer behavior. All right, so let's suppose that the consumer is initially at this equilibrium consumption bundle, point A, again, on the highest possible indifference curve that just touches her budget line. It's the most affordable consumption bundle that's going to make her the happiest. Suppose the price of X increases in this case. If the price of X increases, that means that the most she can buy of X goes down. That means that the budget line will rotate inwards. So there's two things to notice about this change. First, since the budget set is smaller due to the price increase, the consumer will be worse off after the price increase, meaning she will consume on an indifference curve that is lower than the last one, meaning that her overall satisfaction will now be less than what it was before. Second, the increase in the price of X leads to a budget line with a steeper slope, reflecting a higher market rate of substitution between the two goods, meaning that now, because the price of X has gone down, the opportunity has gone up. The opportunity cost of consuming X has gone up. And so to consume more of X, you have to give up more of Y now because the price of X is now higher. And so the rate you can exchange them in markets has now increased as far as X goes. All right. So C is a new optimal consumer equilibrium given the price of this good has now gone up. It's useful to isolate the two effects of a price change to see how each effect alters consumer choice. Suppose that after the price increase, the consumer is given enough income to be as well off as before. So this red line represents a hypothetical amount of income the consumer could be given to be able to consume on the same indifference curve she was on before, meaning to make her as happy as she was before. That's how we isolate the substitution effect. So at that point where the new budget line is tangent to the old indifference curve, the amount of X she's consuming there is going to be different than how much she was consuming before. Basically, the movement from A to B represents a substitution effect because now the market rate of substitution has changed and the rate at which X can be exchanged for Y is now greater. Then she's going to want to substitute away from A to B in order to be able to, buy more of the cheaper good now that's relatively less expensive than the one that had their price go up. So that allows us to isolate the substitution effect, the change in the quantity consumed as the consumer substitutes other goods that are now relatively cheaper in place of the good that has now become relatively more expensive. It reflects how a consumer will react to a different market rate of substitution. Considering the equilibrium at A now, we know that at A, the marginal utility per dollar spent was equal across all goods. But beyond that, when the prices changed, the marginal utility per dollar spent was going to be less for X and Y, and that's what caused her to move along that line. This means that the utility per dollar spent on Y is now higher, and thus it makes it sense for the consumer to substitute away from good X to good Y, which is why she moves along it. Anyway, the movement from XM to the amount of X on C represents the income effect, the other effect based on how overall she feels poor because her income has now gone down because the price of one good has gone up. Anyway, this I won't expect you to know, but it's just meant to kind of help you understand like why this model is powerful, and you can get a lot of insights from it. Anyway, make sure you understand the framework as I explained it and be able to represent it and be able to represent changes to the optimal equilibrium and the terminology in chapter 10, and you'll be okay as far as chapter 10 goes. Beyond that, have a great spring break, everybody. Enjoy yourselves, but work really hard. I want to see a lot of really strong performance in the second part of the course, all right? Take care.